Well, thanks a lot for the introduction. I switched the camera on. I hope everybody can see me right now. I've also noticed the key points, cost reduction, and I hope that all the points could be answered right already through this presentation. Well, just to my person, I'm the responsible project leader for the so-called connected eH2 cycle, which describes by name the industrial sector coupling on the side. Well, many times we have been questioned why Homburg, as an industrial production plant for automotive components, is starting to invest in industrial sector coupling using green hydrogen as energy carrier at such an early stage. Well, to answer this question, just let me present what we are generally faced with. The world around us is changing. It happens in many different areas, not only at home. The world has to deal with an increasing population. Just to give you a number, by the year 2450, 10 billion people will be living on Earth. The rural exodus that has already started will advance, and the asymmetrical distribution will increase in such a way that by 2050, 60% of the world population will live in cities. The climate changes. Just a short glimpse at the weather recordings reveal that the top 20 entries regarding the warmest years are all in the period since 1990. So far, I just gave you numbers, which I'm sure you already knew or you can easily find on the news or internet. And throughout the press, there's an ongoing discussion about 2, 4, even 8 degrees global warming scenarios. But I would like to give you an idea what the real impact of an increase of 4 degrees Celsius means with an exemplary picture. On the screen, you can just see what happens, what is the impact on London. Such impact raises the question, what should be our part or what can we do? Not in our private personal environment, but as a company, as a corporation who takes care, what BOSCH can come to. What does this mean for us? Can we make a difference? What are the chances we have? We as Robert BOSCH take responsibility for climate protection. From the start 2020, BOSCH is CO2 neutral. It means all 400 locations worldwide across all company areas, from development to production to administration. Our slogan, Invented for Life, means also taking care of the environmental sustainability of our production process. That's how we take responsibility beyond the boundaries of the company. Paul just mentioned it. From a global perspective, climate protection is more urgent than ever. According to the International Energy Agency, industry and its electrical consumption account for around 32% of global carbon dioxide emissions. Industry is ahead of traffic. By achieving climate neutrality, we are making an important contribution to the 2050 Paris Agreement on climate change. This requires a global warming limitation well below 2 degrees Celsius compared to the beginning of industrialization. In the slides before, I just showed you the impact of 4 degrees. To reflect this sense of responsibility, and the BOSCH value on sustainability and responsibility is strongly emphasized through the last years. Let me show the contribution of a Homburger production plant regarding a reduction of the CO2 footprint and also how we face the current worldwide challenges with rising costs, new mobility concepts, and high volatility. Several key elements can be named. Reduction of consumption by increasing efficiency and flexibility. Optimize regenerative power generation for our own consumption. Linking up all relevant components by the energy platform. Currently, we have over 10,000 data nodes to make sure we are working on the optimal operating point. Storage and also sector coupling. In the last year, our energy management on site was quite effective, and since 2014, we have been successfully offering our knowledge and an external service worldwide. And now we are going one step further. You still there? Just a short. I'm still.
I think it's gone. It has gone to your notes, Frank, rather than the main slide.
Can you just switch to the slides? So I will go through because my computer just broke in half.
Amy, can you move the slides forward, please?
Amy?
Yes, hello.
Can you move the slides forward for Frank? Folks, apologies for this. As Frank said, his computer's frozen and you're seeing his notes pages. Amy, do you have Frank's slides?
Yep.
Yeah. Folks, bear with us just for a couple of minutes. And just as Amy's pulling these up, Frank, I'll ask you a question. This maybe provides a bit of background.
Yeah.
Employee numbers across the whole BOSCH enterprise, please.
About, I think 400,000.
400,000 employees, and think of that energy
for
footprint.
Years, there was
270,000.
270,000. I think we increased so far.
Yeah.
But as you already mentioned, we have all different. We have white goods. We have all the automotive parts. We have computers and also all sorts of different things.
So it's a lot of employees and a big energy footprint, Frank.
Yeah, you can see that's why it was a big step from BOSCH to raise the point that within 2020 or the whole year 2020, all plants, all administration buildings are all CO2 neutral.
On the energy footprint in your steel hardening, can you quantify the energy consumption in the steel hardening plant with the project we were looking at with HAZEL?
Oh, I have to look at it, but I know it's just a consumption about 7 tons hydrogen per year. But the whole consumption, I have to look at it.
Yeah. So, folks, it gives an idea of the challenge that BOSCH have in addressing their CO2 neutral targets. And it's not just a target; they're actually getting to there, and they're moving forward to that. So hopefully that's us back online. We haven't lost any viewers, hopefully. Amy, many thanks for picking that up.
Yeah, thank you. So I was just telling you that in the last year, our energy management was quite successful that we're offering a knowledge or an external service worldwide. And now we are going one step further, consistent with the spirit of our slogan, Invented for Life. It's just me follow on the next slide. I will just switch. It works just perfect. The connected eH2 cycle. It involves a variety of key sectors for the industrial environment, reaching from H2 generation to distribution to consumption by using green hydrogen as energy carrier. Paul just showed a slide where I mentioned the smart H2. This is the slide which we also present to our plant leaders and also to Stuttgart, just to show the impression of what we're really facing off. Starting point. You see on the next slide, starting point of the connected eH2 cycle is already existing non-regenerative hydrogen infrastructure on site to supply the heat treatment process with hydrogen. You can see it here on the yellow line. Last year, we extended the infrastructure with components which will step by step be integrated in the connected eH2 cycle. A photovoltaic system is currently expanded to 8.3 megawatt peak, as already mentioned, questioned. The BOSCH Energy Platform, a cloud-based software solution for displaying, regulating, and optimizing the energy value stream within these connected units. And the SOFC, which I will describe later on, solid oxide fuel cell for power and heat generation. With the next year, the connected eH2 cycle will expand with all its units connected. An electrolyzer will provide green hydrogen from regenerative excess energy from our photovoltaic or external electricity market stored on site. This consumption of excess energy contributes to the network stability. The green hydrogen will supply the industrial process heat treatment and lower our current carbon footprint. From the economical point of view, these measures alone will not be profitable, even in midterms, which decreasing electrolysis costs. This was one point mentioned already by Paul. The coupling of several use cases is promising. We will operate our SFC with the stored hydrogen, for example, to smooth peak loads. Just to give you an impression, a completely leveled energy demand of the Hamburger plant would save millions of euros in network fees each year. Alternatively, the SFC can be operated with a mix of natural hydrogen gas with a positive effect on return of investment. A further step is the integration of the mobility sector. One positive aspect of the industrial environment is the predictable mobility requirements, which are implemented in our hydrogen cycle design. In this way, we can become the nucleus for hydrogen mobility. Due to the sector coupling and flexible, scalable design, this doesn't only work for Hamburg. We already checked this one. It also works for other BOSCH factories and other industries. One key element for the re-electrification and heat generation is the SOFC, a scalable gas-to-power unit. On site, we have one of the first BOSCH prototypes in use. You can see here the target values, which I just mentioned on the slide. 60% electrical and 85% overall efficiency. 3 kilowatt thermal output and 10 kilowatt AC power nominal load. And big point is it has an extended and rapid power modulation and the scalability up to several megawatts, just by aligning them, as you can see on the slides here. The SOFC stands for Bridge Technology, from natural gas to hydrogen, with a wide variety of applications and use cases. For example, we have here the decentralized energy, we have the data center, base energy, and the building blocks. It is a cost-competitive product, and we are pleased to integrate the prototype in our eH2 cycle as a use case for sector coupling. The Homburg plant is producing one of the core elements of this prototype. Working on the connected eH2 cycle brings us in contact with a large number of innovative products and components. In times of structural changes, this is very important to create employment. That is the reason why the eH2 cycle is part of our location concept. The final chapter of this lecture will deal with the sector mobility, predictable mobility in the industrial environment. In short, the fuel cell is on its way. For heavier vehicles, we are working on alternatives such as fuel cells in order to provide the right drive for every application. BOSCH already has several partnerships with vehicle manufacturers, an example Nikola, an American startup. Well, the question arose, why investigating a fuel cell? What is the motivation? Well, we have upcoming clear requirements in the region to reduce emissions and therefore a preferred position of e-mobility. Fuel cell electric vehicles combine a battery, the electric vehicle with an additional hydrogen storage plus a fuel cell to convert hydrogen into electric energy. Target segments, as you can see on the slides, the driving range between vehicle segments are, for us, the passenger cars, the commercial vehicle and long distance, and heavyweight users with rapid refill, below 5 minutes for 600 kilometers. For this fuel cell technology, we are producing 3 components in our plant, which I just can show you, just to give you an impression that we're working on every part of this hydrogen circle. As you can see on the screen, this is an electric air compressor, which is required to supply the fuel cell with oxygen. The second part is the hydrogen gas injector. While it provides the correct amount of hydrogen just in time to the engine. And last not least, we have the anode recirculation blower. It just delivers the right amount of hydrogen to the fuel cell system. Well, these are 3 main components which we produce just for the fuel cell system. And just to finish the presentation, I would give a short summary. We as BOSCH will achieve CO2 neutrality worldwide in 2020. The sector coupling in the industrial environment, also so-called connected eH2 cycle, plays a significant part in it. We will successfully build up this hydrogen cycle over the next few months and years. And there's also one point mentioned at the beginning. As a production plant, we see the opportunities that new H2 products offer for the environment and for employment. So that's all the slides which I wanted to present, and thanks you for listening. And I think now back to Paul again.